Welcome to Mathematics. And this morning, this day, we are going to tackle a special lesson that was requested by Kyla and Gian. So shout out to Kyla and Gian. So our topic is graphing linear functions or equations using slope-intercept form, which is y equals mx plus b. Alright, let's proceed. So for our first example, we are going to graph the function 3x minus y equals 1. Alright, so before I can graph that, let us transform this into the form of slope-intercept, or into y equals mx plus b. Okay, so to make it happen, we need to transfer our y on the right side and also 1 on the left side. Okay, so it's going to be 3x minus 1, okay, because we have a positive 1 here, and since it crosses the equality sign, it will have its additive inverse, which is negative 1, equals y. Okay, so we have this negative y, and once it transfer or cross the equality sign, it will have its additive inverse, which is y. Okay, so we already have our slope-intercept form. So let me arrange it a little bit. So we will have 3x minus 1. Okay, so I just transferred it. Okay, so we already have our slope and we have our intercept. Okay, so our slope here, we all know that our slope is rise over run. Okay, and our slope here, we have this negative 1. Okay, since we have 3, okay, we have 3 here, so we don't see any denominator here, right? So automatically the denominator there will be 1. Okay, so it will be 3 over 1. And you would ask me, sir, where did this 1 came from? Okay, if you would try in your calculator, guys, any number, if you divide it by 1, its answer will be still the same. It will still be the same number. Okay, so that is how it came up with that idea. Okay, so let's say, for example, we have here any number, let's say 3. Okay, let's divide it by 1. Still the answer would be 3 itself. Okay, so for same as the other numbers. Okay, so now let's start to graph this one. So I will name it as my x and y axis. Alright, so first things first, guys, we are not going to start with our slope. Okay, we are going to start with our y-intercept, which gives us negative 1. Okay, so y-intercept, it means that we are going to intercept at y-axis. As you can see, this is our y-axis, right? Okay, so the negative 1 of y-intercept is we have here, okay, negative 1. And it says we are going to rise 3 units. Okay, so we'll count 1, 2, 3. Alright, but we will not end there because we are still going to run 1 unit. Okay, so it's positive, right? So we are going to go to the right. Okay, 1 unit. Okay, I see. Okay, that's it. Actually, you can already connect that. But if you still doubt, you can have your third point, same as rise over run. So we can count again from here at this point. We can count 3 units again. 1, 2, 3. As you can see, we rise up 3 units, and we are going to run 1 unit. 1. Okay, so in line with 2. Okay, so those are my 3 points. I can now connect it with my straight edge. And as you can see, this will be my okay, I'm going to go back with my problem, which would be 3x minus y equals 1. Okay, pretty simple, right? Okay, so for our second example, you can try this one out for yourself. So you can pause it right now. Okay, so I'm assuming that you are already done. So let's try to check if you are right or wrong. Okay, so first we are going to transform this one into slope-intercept form into y equals mx plus b form. Okay, so I will rewrite my equation. Okay, so I'm going to transfer my x on the right side, okay, so that my y will be left on the left side. Okay, so it will be 2y equals 4. So it is positive x here. So once I transfer that or cross that in equality sign, it will have its additive inverse, which would give me negative x. Okay, next I'm going to divide both sides by 2. Okay, so I will have y equals, I can have that as 4 over 2 minus x over 2. Okay, it's still the same. You can actually try to figure this one out. Since they have the same denominator, you can have that as 2 as the LCD. And 2 divided 2 is 1, 4 minus x. Still the same in our top equation, right? Okay, next. 4 divided 2 would give me 2. And of course, it will give me x over 2, right? Or I can rewrite that as 1/2 of x. Okay, 1/2 of x. Sir, how did you do that? So as you can see, we can have this as x times 1 would be x over 2. Still the same. Okay, so lastly, I'm going to just rearrange this right side equation into y equals mx plus b, because as you can see, this is our x, right? So it would be, so when you rewrite or rearrange in the same side, do not change the sign. Okay, so it would still be negative 1/2 x plus 2. Okay. Okay. So we have negative 1/2 here. So our slope would be that negative 1/2. Okay. So as you can remember, our rise is on the numerator, so it will be negative 1, as you can see. So later on, as we graph that, we are going to rise negatively. So we're going down. Okay. And our run would be 2 units. Okay. Of course, our y-intercept would be 2. So which means we're going to start at y-axis 2 units. Okay. So now let's start graphing this one. Okay. So again, we're going to start with y-intercept 2. Okay. So this is my y and my x-axis. So 2 here. Okay. And I'm going to rise negative 1. So instead of going this one, it is positive 1. So negative 1 is going downwards, right? So we have negative 1. And I'm going to run 2 units. 1, 2. I see. Okay. So if you're still doubting with your 2 points, you can still continue that one. So you are going to rise negative 1, 1. Okay. And you are going to run 2 units. 1, 2. Okay, there you go. You can connect it with your straight edge. Okay, as you can see, our graph is not that accurate. Okay, so make sure you are using an accurate graph. You may use your graphing paper if you want to. And of course, I will name that graph according to its given, which would be x plus 2y equals 4. Okay. So, before I leave, I'm going to leave you with our third problem. You can try this one out, and you can check it later for our second part of our video. See you.